Well, hello guys, here Mr. G with another video for the rate of reaction, grade 12. This time we're going to be answering the multiple choice of the test on rate of reaction. The question 1 is always a multiple choice and is a lot of mark. But before we answer, please subscribe for the channel so you can get all the videos I post on regular basis. Various possibilities options are provided as answers on the following questions. Choose the answer and write only the letters A to D next to the question number in the answer book. So question 1.1 say which one of the following is true for activation complex. Alright, now remember, activated complex is the unstable stage of transition where bonds are broken and new bonds are forming. Okay, so the options they are stable and has low potential energy, no. Unstable and has high potential energy, that one is the correct answer without even reading further on. C, stable and has high potential energy, no, because it is not stable. Unstable and have low potential energy, no, because it is a high potential energy. Remember, the activated complex, if you have the graph, like for instance this graph here, whatever is exothermic or endothermic, the activated complex is always the top. So the activated complex is always there on top. Or here the activation potential energy is very high. So the correct answer is B. Let's go to question 1.2. In an exothermic reaction, there is a decrease in internal energy. There is no energy change. The activation, okay, there is always energy change, so B cannot be. The activation energy is always more than the heat of the reaction, and delta H is positive. That is exothermic reaction. So all of them are incorrect except for A. There is a decrease in the internal energy. In the exothermic reaction, guys, which this is the graph for exothermic energy, you can see that the energy of the substance decreases. The internal energy decreases. The energy of the reactant is greater than the energy of the product. Let's go to question 1.3. Using a catalyst would increase the rate of the reaction by decreasing the energy and increase the average kinetic energy. Not correct. The catalyst doesn't increase the average kinetic energy. Using a catalyst increase the reaction rate by decreasing the energy and decreasing the number of effective collision is wrong. The number of effective collision does not decrease. Increase the reaction rate by increasing energy and increasing the average kinetic energy, it is wrong. It does not increase the energy, it lower the activation energy. Increase the reaction rate by decreasing energy and increase the number of effective collision, so the correct answer will be 1.3. Increase the rate of reaction by decreasing the energy. This one is the activation energy. That is the activation energy. That is 1.3. Question 1.4. The potential energy diagram below shows the energy change that takes place during a reaction. What is the activation energy for the forward uncatalyzed reaction? And they give you different options there. But the activation energy, guys, is this one here. This energy here is the activation energy. And therefore, if you calculate it, this one will be equal to 650 minus 200. And this is going to be equal to 450 joules. So guys, the answer is then also D. That is the correct answer there. We're going to the last one of this multiple choice and the last one of the video. Which one of the following graphs show the mass of a catalyst against time during reaction? It's a very good question. I like this one. Remember, the mass of the catalyst doesn't get affected because the catalyst does not form part of the reaction, it's just speed up. And therefore, guys, it's very simple. The mass must stay constant. The answer is C, and this is the end of the multiple choice. Thank you for watching. I hope it helps. Subscribe for the channel. I'll see you next time. Mr. G here.